So now we will start our session today. We will start by doing a revise on circle theorems. Okay.
Okay.
So at the beginning, we need to draw a circle. So you know that any circle should have a center. So this is a center. And if I draw a line, a line, just 1 second. If I draw a line from here till I reach the circumference, this is called what? This is called a radius. And if I draw another line connect from this center till this circumference, it is called also, it's called what? It will be called
A radius as well.
yes, radius. Now, if I started to connect this line till I reach the circumference here, this is called what? This is called now diameter, because this is a radius and this is also a radius. So now let me call this AB. So AB is a diameter. And AB, by the way, equal double the radius.
Or
okay. This is okay. So this is clear, and I think you know very well. Now, if I make something like that, this is called now what? This is called
a coil.
very good. Okay, and this area now is called what? And this is something maybe new for you. This we will call this area segment.
No, I know this.
Okay. Let's make it as a revision because some maybe all you know, but I will tell you how to use it. Okay.
Okay.
Another important thing is that this area here is called what? Do you know?
Which one?
This area. It is called sector. So we need to differentiate between sector and segment. Sector is like this thing, like a piece of cake in the circle. Take it as it like this. So it is like a piece of cake, okay, or a piece of pizza. Okay, so this is sector. A segment is an area which is below what? Below the chord. You see, it is from, you know that the chord is connecting the circle from its circumference, from two sides with circumference. So this is called a segment. But the sector is like a piece of cake between the radii, between two radii. Okay?
Okay.
So this is important. What else? If I draw a line like that, okay, and I drew another line like that, what is this called? This is called what?
Which one?
These lines.
Tangents?
Yes, these are called tangents. And that one is circumference. Okay, so these lines are called tangents. Now we need to know about the theorems. This all I think you know. We will go through some rules. Okay, so
Okay.
let us start with rule number 1. If I have a circle, let us draw it better. If I have a circle like that, and I have a line, two lines like this, okay? What are these called? They are called what? Do you know?
I'm not sure.
No, we just said it. This is called chord. This is called what? Another chord. Okay? And this is the center.
Okay.
Okay. And now we have some shape. This shape is like what? Shape. This shape is like arrow. You can see like an arrow, yes?
Hello?
Yes, yes. This shape
Mm.
is like an arrow inside circle, yes?
Yeah.
Arrow. Okay. Okay. You have here two angles. This is angle and this is another angle. You see them?
Yes.
Okay. This is angle and this is another angle. These angles, okay? These angles, let us say this is angle B and this is angle A. So what is the relation between A and B? B equals double of A. So this is
A.
the rule number 1. Why? Because they are sharing the same arc. Okay, so they are sharing the same arc and B is in the center. So I have something to say to remember this rule, that always the center is more crowded than the city. So to memorize that, always the center is double any other angle. Okay? Understand?
Yes.
Okay. This is rule number 1. If I give you an example, I want you to solve. I have here a circle, and I have here point P. Then I connect this point till this point, another point, it is point A. I have here point C, and I have the center here. Now, this is like this, and this is like this. First thing I have what? I have arrow shape. So when I have arrow shape, I remember rule 1. Rule 1 says that the angle in the center, this angle, is double. Change the
The
star.
angle.
Yes. So this angle is double this angle. So if I told you, if angle AO, this is O, E equal 96, then angle ABC will equal what?
48.
Okay, very good. This is rule number 1. Rule number 2. It is about circle as well. We will have circle. And I'm connecting like that. And here is our center. Okay. What you can see here, I can see that there is a right angle here. This is a right angle. So what is in this? This is a chord, and this is a diameter, and this is another what? Another chord. So this angle is always 90 degrees. Whenever you see this shape, if I name this as C, E, A, this angle A, B, with 90 degrees. Okay?
Okay.
Why this angle is 90 degrees? By the way, this rule is a special case from this rule. Tell me why. Why? Simply, it is the same, but here we have this angle is what? 180. So now this is half of this one, so it will be 90. You see? So because the central angle here, central angle, in this case, equal 180. So this angle, which is measure of ACP, will be equal to half of this central angle, so it will be equal to 90. Clear?
Yeah.
So this rule we call angles in semicircle. This is angles in semicircle because the arc here is like a semicircle. I want you to always that whenever we work about circles, we search for arc.
Mister, you're lagging.
For arc. So I'm searching for arc here.
No, you're lagging, Mister.
You can hear me now?
Hello?
Hello?
Yeah, now I can hear you.
Okay. So I'm always searching for the arc. Here my arc is what? Here my arc is semicircle. So when my arc is semicircle, so this is always what? 90. Here my arc is somehow an arc, but it is not semicircle. So there is a central angle, and we say that the center is always crowded, so the center is double anything. You understand? But they
Yeah.
are both sharing the same what? The same arc. Okay? Okay.
Okay.
Let's move to rule number 3. I think these rules are very, very important, as you can see. Because all your exam I mean all your exam, the question of yesterday exam was about these rules. And they were all in one question. Rule number 3. If I have a circle like that, and I have now you can see that I have what? I have here an angle and this is another angle. But you can easily see that they are sharing the same arc, right? These
Yeah.
angles are sharing the same arc. So I can easily say that sharing the same arc. So if I name this angle to be angle X and angle Y, so angle X equal angle Y. This is rule number 3. So please don't confuse with this rule and the other two rules or the previous rules. Okay? Because here we have a central angle, and central angle is the controller of these two rules. Okay? But here we don't have central angle. Okay? And
Yeah.
these angles, you understand? These angles are equal, but we are looking for the the circumference or the arc they are sharing. Okay.
Okay.
For example, if I connected here something like that, and I made this to be angle C, then A will be equal to C, and they are all half of that one. You understand?
Yeah.
Okay. Rule number 4. This is called what? This is called cyclic weld. What does mean cyclic quadrilateral? Cyclic quadrilateral is a polygon or a quadrilateral inside circle. And this cyclic quadrilateral has a special rule. What is its special rule? Special rule that the measure of each two opposite angles, their sum will be equal to 180. So this is the special case of a polygon which is inside a circle. So whenever you see something like this, and this polygon should have its vertices, its 4 vertices, lying on the circumference of a circle. Lying on the circumference of a circle. In this case, each two opposite angles, their sum will be equal to 180. So if I give you something like that, and we have here D, C, E, A. You see this?
Yeah.
Okay. What I want. I'm sorry. Let me draw from the beginning. This is A, B, C, D. And you are given that angle ABC is equal to, for example, 84. And angle BCD is 120. Can you find the other angles?
One is 100 and the other one is 78.
Okay. But it's not 100, it is 100, it is 94.
What?
Which one is 100? This one?
Yes.
Why 100?
180 minus 80.
This is 84, 84. Okay.
Ah, okay.
Rule number 5. And by the way, it will be sync for the last. Rule number 5. When we have circle like that, and we have segment, this chord, and this is another chord, and this is another chord. You see, 3 chords, and then I have a tangent like that. So if I have angle here, this angle will be equal to what? This angle will be equal to that angle. That angle. Why?
Okay.
Because this angle is between tangent, this tangent to a circle, and one of the chords. Take care from this way to recognize it. خلي بالك من الأول دلوقتي. Between
Okay.
tangent and chord. This chord is opposite to some angle. So this angle is equal to that angle. يبقى angle دي ما بين التانجنت والكورد. يبقى الكورد اللي قصاده انجل جوه الدايره هو اللي هيساوي الانجل اللي بره دي. تمام؟ اوكي.
Okay.
If I need to find another 2 angles here using the same theorem, I will find here this is an angle, and it is an angle between the tangent and this chord. So opposite to this chord, this another angle, this one. So these 2 blues are equal, and these 2 reds are equal. Is it clear?
Yeah.
Because this is difficult sometimes. So if I have here another example, point C, point A, and a connection between point C and point A is like that. And there is something like that. Here is point A, a point B, and there is a chord like that. And we have our tangent. Now, this is my angle. So it will be equal to what? This angle, right?
Yeah.
Okay. If I have that angle, will be equal to what?
To this one.
Okay. And
Yeah.
if this is the center, this will be the diameter. So this angle will be 90, and that angle will be 90. Understand?
Yeah.
But if this is not the diameter, it will be any angle. So these are 5 rules that we have, and the last 2 rules I can write here because there is no more space. I will write here the last 2 rules. Rule 6 and 7. If I have a circle like that, and I have some tangent like that. Okay, this is tangent. And as I said before, if I have here some center, so, and I connect this like that, this is what? This is the right angle. Okay?
Yeah.
The last one I will draw also here. If I have change colors. If I have tangent like that, and another tangent so they are both tangent. And now I can easily say that these two tangents are equal. Okay? Okay? These
Okay.
are seven rules. These are 7 rules. We should memorize very well. Now we will continue solving this. So if you come here again, and let us check our rules now. We have A, B, C, D lie on a circle. A, B, C, D lie on a circle. Center is O. TA is a tangent. And ABC is equal to one ABC. What is ABC? ABC is equal to 131. Angle ADB is equal to 20. So this is an angle. So first rule we can say, first thing we should think about, we search for what? We search for
The rule.
yes, the arc. Okay, this is our central angle. Okay, so we need to find angle ADC. ADC. Okay, so
Yeah.
this angle, yes, we proved that one is what? Is a cyclic quadrilateral. Okay, so
Yeah.
angle X plus angle plus this angle is equal to 180. So we found that it was 49. Now we need to find angle AOC. AOC, and it is a central angle. This central angle have that arc. Okay,
Yeah.
and that arc is also shared with which one? With angle x, right? But
Yeah.
this is a central angle. So this central angle is equal double of x that we have found, which was 49. So it is 2 times 49. I think it's clear now. Yes?
Yeah.
Okay. Third one was to find the angle PAT. PAT. PAT is an angle with a tangent and some chord. So there is a chord. We look for the angle opposite to this chord and sharing the same arc. It is 20. So this angle is called
20.
this. Yes, this angle is will be equal to 20. Okay.
Yeah.
The last one is to find OAB. Where is O?
It's in the middle.
OAB. Okay. OAB. Okay. This one is from center to a tangent. So this angle OAT is right angle, but OAB is this angle plus this small angle. So
Yeah.
this angle is equal 90 minus the one that we just found, which is 20. So we find a LB30.
70. Yeah.
You understand? Is it clear?
Yes.
I think now it's more clear.
Yeah, it is clear.
Okay. Okay. Now we need to solve this one. The diagram shows a sector of a circle. No, it's again a circle of radius 8. So you take your time and solve it. You have 2 minutes to think about it. 2 minutes.
It's this. To find area of a sector.
Yes, yes. Think about it. You know?
Yeah, but that's how you find area of a sector.
Yes.
Yeah.
You already said before many times how to
What?
find. We already mentioned the rule many times before.
Yeah, I just wrote it.
I can't see really. Wait. No, I can't see where you wrote it.
It's here. Can you see it?
No, nothing here.
Subway. Now it's
Wait.
it's theta over 360 pi r squared.
I know the rule. I want to see your writing. Where is which? Just one second. Write your rule
I wrote it.
and say what. انت بتكتبي اشمعنى بيظهر لي انا مش عارف. Wait. طب انا عايزه يطلع هنا. شايفه الشاشه عندي عامله ايه؟
عادي it's the question.
طب لو انا كتبت كده ما انا اشمعنى ما بتطلعليش؟ Okay, no problem. I will write. So the rule will be as follows: the area of sector is theta over 360 times pi r square. Right?
Yeah.
This is theta. And the diagram shows here is the radius here is 8, and the length of the arc is what? 6.
The length of is 6.4.
So, how to find the area now?
Okay. First, we need to find the
Need
theta.
to find theta. How to find theta? There is another rule called
It's half
arc length equal theta r.
or
So theta equal 6.4 divided 8.
divide.
You know it? You know this?
Yeah.
Okay.
6.4 divided by 8 is equal to 0.8.
Yes.
I cannot see this.
I will share again. Okay.
Yeah.
So we need to find theta as I said before, or we can do another way. How much you find theta?
0.8.
0.8.
Yeah.
Okay, but you find it in radian now, you know, because if
What?
this is theta measured in radians. This is theta measured in radians. This is the rule if theta is measured in radians, but if it is measured in degrees, it will be theta over 360 times 2 pi r. This is equals what? This is our arc length. You understand? So
Yeah.
theta will be equal to how much is our arc length? Our arc length is 6.4 equals theta over 360 times 2 pi r. So theta is equal to 360 times 6.4 divided by 2 pi r. Now find it, please.
يلا 1 second. Mister, we use mode radian or degree?
Degree.
$360 times 6.4 over 2 pi. What R is 8?
8? No. Check again.
Yeah, R is 8.
Yes, R
Radius.
is 8. Yes, R is 8.
It's 45.83.
Exactly. You will find it to be 45.8. Okay, degree. So we will substitute here to find the area using this rule. So area will be equal to theta, which is 45.8 degree over 360 times pi times 8 square. And you will find it to be 25.
25.6.
Okay, clear?
Yeah.
So we write here 25.6 centimeter. Oh, no centimeter, but it was digits. Anyway, I want you to know the idea here. Here, he asks for the area. So at the beginning, I wrote the rule. A equals theta over 360 times pi r squared. I have two rules for area and two rules for arc length. Okay? In case of radian, I will say that the area of a sector, I will write it as well. In case of radian, will be theta will be equal to half r squared theta. Okay, this is radian. I mean A. A equals in case of radian. Okay, so this is in degrees. So I prefer to work all in degrees. Okay, so in degrees, theta over 360 times pi r squared. This gives us the area, but I don't know theta. So I have to go to the rule of degree in case of arc length. Arc length equals theta divided also by 360, but this time times 2 pi r. I found theta is 45.8. Then direct substitution in this rule, I find what the area. Simplify the following. It is 2x squared plus x minus 15 over ax plus 3a minus 2bx minus 6b. I want you to do it by yourself and tell me the answer.
So where'd you get the 30 from?
I told you to do it yourself. I will.
X minus.
I already explained this before. We will
It's
multiply.
not 10 and 3, it's 6 and 5.
What?
It's not 10 and 3, it's 6 and 5.
Yes. I will tell you. Wait. We multiply this by that one. We get 30.
Yeah, to get x squared alone.
Okay. So then we will do what? We need to find the two factors of.
Factorize.
Okay. What they will be?
It's gonna be x plus 6 and x minus 5.
Okay, 6 and 5. but we need to remember that we multiply by 2, so we will divide here by 2 and here by 2. So this will be here. 2 will come here, and we will remove from this one, and this will be 3.
Mr. Why do you divide by 3? By 2, sorry.
Okay, again. أنا أصلا هنا عملت 2 times 15 فلازم أرجعها لأصلها. I want to back. So I want to remember that I multiply by 2. That one. Whenever I multiply by any number here, I must divide at step. If this was 3, I will divide those factors by 3. Understand? And now, after I divide, I'm checking. If this one is divisible, I will write like this. That one is not divisible, so I will put it here and put this number here. And this is x, and this is x. Now I'm looking for signs. Signs is negative, so both are different signs. But the one which is larger will take the middle sign. So that one is 6, and that one was 5 before division and before dividing. So that one will take negative. So this is plus, this is minus. So finally, that one will be 2x minus 5 times x plus 3. Divide. Here I'm taking a as a common factor, will be x plus 3. This one I will take 2b as a common factor, will be x minus or plus here because it is minus 3. Okay, so again I will take a common factor, will be x plus 3 as a common factor, so it will be here a minus 2b, and here it is 2x minus 5 times x plus 3. Now this will be cancelled, so final answer will be equal to 2x minus 5 over x over, a minus 2b. So this is the final answer now. I will write it like this, 2x minus 5 over a minus 2b. You understand?
Yeah.
So you have to solve this alone, please.
Okay.
Okay.
We took these last year, but I totally forgot them.
Okay. Now we have, this will be our last question today. We have here y radical y square equal radical x and y equal radical x, and find them. We will substitute y here, so it will be, this is equal to x power 1 over n. So we'll put it here, x power 1 over n, all to the power 2. Okay, so now x equal 2 over n, all to the root 1 over, all under third root. So this is x power 2 over n all over 3. You understand?
Yeah.
All power 1 over 3. So this is x power 2 over 3 n. Now he gave me information that this is equal to what? X power 1 over 6. So 2 over 3n equal 1 over 6. So n is equal to 2 times 6 over 3. So it will be equal to 4. Is it clear?
Yeah, it is.
Okay. This is our last question today, and we will continue tomorrow. Okay, please try to come at the time. Okay?
Yeah, I'm sure. Yeah, okay.
Okay, Hannah? Okay, please book tomorrow. Come at time, please. Okay, if you have
Yeah,
any question,
tomorrow.
if you have any question, ask me. Okay?
Yeah.
Okay.
Thank you, Mr.
I need you to. I will send you this description and the rules for circle. I need you to study these rules well, please. تذاكر القوانين دي كويس عشان بتيجي كتير. Okay? Okay.
Okay.
Bye.
Bye, Mr. Thank you.